Hi, and welcome to a video on binomial multiplication. In this video, we're going to look at a specific pattern. The pattern that we are going to look at is the quantity x plus a times the quantity x minus a, which results in the difference of two squares. So, in this video, we're going to do three examples. We're going to do example 1, which is a very simple example, example 2, which is a little more complex, and then example 3. And I'm going to show you how to use this shortcut instead of the longer way to find these products. And then we're going to compare the shortcut that we used with the area model that you already know how to use. So let's take a look at this first example. Now, the key to using the shortcut is to understand the meaning of this formula. We need to identify what A and B are in our example. So if you look at A and B are repeated in the first binomial that is a sum and also in the second binomial which is a difference. So if we compare our example with the formula above, we can say that RA is the x value because it's present in both the first and the second binomial. And then the b value would be 17. So for this problem, b equals 17. So if I'm going to use the formula, I'm going to say that this is equal to a squared minus b squared, and I'm going to replace the a and b values that I have. So here a is equal to x, and b is equal to 17. So I'm going to put x in here. I'm going to put 17 in here. And now we know that we have x squared minus 17 squared. And you can do two things. You can leave it 17 squared, or you can multiply it out. So if we multiply 17 times 17, we get 289. So that would be x squared minus 289. And that is the product of x minus 17 times x plus 17. So you can see, as you get used to using this pattern, it can become a very quick way to get your final result. Let's compare this with the area model. If we were to use the area model, we would take the two binomials and make a 2 by 2 array for the two binomials. So we would do x minus 17, x plus 17, and we would find the product. So we've got x squared minus 17x plus a 17x, and then a 17 times a negative 17 would be a negative 289. When you collect like terms in this area model, you see the positive 17 and the negative 17 effectively cancel, leaving you with just x squared minus 289. So you can see we get the same result either way. If we use the shortcut, we can get there rather quickly. If we use the area model, we get the same answer. Okay, let's take a look at our second example, which is slightly more complex. If we look at our second example, we have our A, which would be our A in the formula, and we have to be a little bit careful because this has a variable of A. But we're going to say our A is equal to 2A because it's the same value or the same expression in each binomial. And then the B value would be equal to 11 because we have a plus 11 and a minus 11. So this fits our a plus b times a minus b pattern. So when we multiply these two binomials, we're going to end up with the first expression, 2a quantity squared, minus the second expression in each binomial, which is 11 squared. And then we just multiply those out. So we get 4a squared minus 121. That's pretty quick, and the better you get at this, the quicker it can be. All right, I'm going to quickly do the area model so you can see how that pans out. And you can see when I finish the area model, I get the same solution that I got when I used the shortcut up above. All right, we've got one more example. It's a little more challenging. Let's take a look at that one. Here's the most complex of the three examples. At this point, we should be getting a little bit better at this. We notice that we have a 3h and a 3h. We have a plus and a minus, or excuse me, a minus and a plus, and it doesn't matter which order these are in. And then we have the 10k and the 10k again repeated. So in this problem, our A is 3h, our B is 10k, and if we replicate our a squared minus b squared pattern, we're going to get a result of 3h quantity squared minus 10k squared, which results in 9h squared minus 100k. All right, again, I think it's important to compare that with the area model, so I'm going to zip through that for you. All right, so here's my check, and we can see that when I worked out the problem above, I missed putting that square on the k. I squared the 10 and got 100, and I squared the k. This should have a k squared on it. So a nice way to check your work and verify or justify that you haven't made a mistake is to do the area model as well. All right, I hope this pattern makes more sense to you. Thanks for watching the video.